Let's look at OpenStax University Physics Volume 3, Chapter 1, Problem 70. Three polarizing sheets are placed together such that the transmission axis of the second sheet is oriented at 25 degrees to the axis of the first, whereas the transmission axis of the third sheet is oriented at 40 degrees, in the same sense, to the axis of the first. What fraction of the intensity of an incident unpolarized beam is transmitted by the combination? So let's draw a diagram first. We know that we have three polarizing sheets, and I'm going to just pick a direction for the first polarizing sheet because they're telling us the angles of the subsequent polarizing sheets with respect to the first one. So that's my first polarizing sheet, and then I'm going to have my second one, and it makes an angle of 25 degrees relative to the original. So this line and that line are parallel to one another, and the angle is relative to that. So I'm going to call this angle, 25 degrees. Then the third polarizing sheet, so that's over here, makes an angle of 40 degrees relative to the first polarizer. So I'm going to draw that. Well, it's not very great here. So that is my 40 degree angle. Looks very much like the 25 degree, but it's not supposed to be. And then we also know that we're passing unpolarized light through the combination. So we have unpolarized light going like this. So these are the electric fields every which way. So they will go through the first polarizer, the second polarizer, and then emerge on the other side. So what we know are the angles that I already drew there. So we know that theta 1 is 25 degrees. And then I have a theta 2 that's 40 degrees. And what we're looking for is the fraction of the intensity of the incident beam transmitted. So I want the final intensity divided by the original intensity. So I am assuming that this unpolarized beam has an intensity I0. All right, so we have two equations. The first one applies when the original light passing through a polarizer is unpolarized. And that's what we have in this case. The electric fields have a whole bunch of different directions, and that means that the first time it passes through a polarizer, it will organize the electric field. It will just make it go up and down in this case, and half the intensity of this light will be lost. So that means that we have I0 over 2 here, and the orientation of the electric field will be in this direction. So I'm going to write this as, let's call this polarizer 1, call this polarizer 2, call this polarizer, or analyzer, I guess, 3. So I will say that the intensity after the first polarizer is the previous intensity divided by 2. All right, now we have polarized light, and we have to use this second equation. So we know that the light intensity after this second polarizer will be the intensity before, so that's I0 divided by 2 times cosine squared of the angle between the new polarization direction and the previous transmission axis. So we will have here the previous, so that's I0 divided by 2 cosine squared 25, and that's a little bit of a mess there. Sorry about that. And then the orientation is going to be parallel to that of the polarizer. So this and that have the same orientation. So I write that I2 is the previous intensity, I1, cosine squared theta 1. So that is I0 divided by 2 cosine squared 25 degrees. Now we have this polarized light passing through a new analyzer, a new polarizer, again we have to use this equation. And now we need the angle between this orientation and the new orientation. But both of these were given to us as a function of the first orientation for the polarizer, which then means that the angle that I'm interested in is the angle between that direction, I'm going to make it look like this over here, and the new direction. So that means that the intensity here is the previous intensity, I naught divided by 2 cosine squared 25. And now the cosine squared will be the angle between this orientation and the new one. So it's the angle between the 40 degree and the 25 degree, and that will be 15 degrees. So let me write the complete thing here. I3 is I2 cosine squared, and the angle is what I called theta 2 minus theta 1. So that is I naught divided by 2 cosine squared 25 times cosine squared 15. And what I'm looking for is the final intensity divided by the original intensity. So I want I final over I initial, and that's I3 over I initial. So that will be cosine squared 25 times cosine squared 15 divided by 2, and that gives us 0.383.